In this video, we are to state whether this second order PDEs are parabolic, hyperbolic, or elliptic. So to start with, number 1 here, we have di square phi over di x squared plus di square phi over di y squared equal to 0. Remember our formula, which is b squared minus 4ac minus 4ac. So now let's also consider this illustration for typical second order PDE. We have a di square, say u, over di x squared plus b di square u over di x di y plus c di square u over di y squared. So comparing this with this now, we are going to have di square phi over di x squared plus, let's put 0 di square phi over di x di y, so that if 0 multiply this, everything will turn to 0, so there will be no need for that. So this is di square phi over di y squared. So comparing this with this now, comparing this, let's call this equation 1, and then comparing it with equation 2, let's compare these two. You discover that a here, the coefficient of a here is 1, the coefficient of b here is 0, and the coefficient of c here is 1. So let's solve this and see. So substituting this here now, we have b to be 0, this minus 4, we have a to be 1, and we have c to be 1, and this is minus 4, which is less than 0. So it is safe to say that 1 is an elliptic. It's an elliptic. So 1 is elliptic. So let's look at the second example, the second question rather. The second question here, we have di square u over di t square. Let's bring this to the left hand side, minus a square di square u over di x square. So also checking this here now, comparing it with this, what we have here, you discover that a is going to be equal to 1, and b is equal to 0 as usual, and c is equal to minus a squared. So let's compare it. Let's substitute it into this formula. We are going to have 0 squared minus 4, we have a as 1, we have c as minus a squared. So multiplying this now, you are going to have 4a squared, which is greater than 0. So this is hyperbolic. Number 2 is hyperbolic. So let's go down to number 3. Let's look at number 3. So remember, we are dealing with second order PDEs. So that means all of this side we are not going to look at. We are not dealing with this. We only focus on these first 3 terms here. So this is number 3. So we have here a here, clearly a is 1, and b is t here, and we have c to be x. So let's substitute this into this formula now. Let's substitute this in this formula. If we do that, we are going to have t squared minus 4 multiply a, which is 1, and c, which is x. So this gives us t squared minus 4x. This gives us t squared minus 4x. Now this is not actually well defined to know whether it's elliptic or hyperbolic. So what are we going to do next? So let's look at the first condition here. The first condition is that for this equation to be elliptic, t squared should be less than 4x. That is elliptic. For it to be elliptic, t squared should be less than 4x. Let's take for instance that t is equal to 1. Then that means 1 squared minus 4x is going to give you definitely, and if x is equal to 1 say, then this is going to give you -3, which is less than 0. So for this equation to be elliptic, then t square must be less than 4x. So the second condition here is that for this equation to be parabolic, then t square should be equal to 4x. This parabolic, t square must be equal to 4x for this different PDE, partial differential equation, to be parabolic. So what will make it to be hyperbolic? For it to be hyperbolic, it means t square must be greater than 4x. That is what will make it hyperbolic. T square must be greater than 4x. This is our example 4 now. From example 4, we have a here. We have a to be equal to 1, and we have b to be equal to 0, and c is equal to -c squared. So let's also check this out and see what we got there. So this means this will be 0 squared minus 4 into a, which is 1, multiplying c, which is -c squared. This will give you 4c squared, which is greater than 0. So that means example 4 is hyperbolic. So with this, we have come to the end of this video. Please like this video, subscribe to this YouTube channel, and don't forget to hit the notification bell to get notified each time we upload a video. Thank you.